Here's a simple electric circuit to help us summarise our electrical equations which we use in circuit theory. And this circuit is simple because we've just got a 12 volt battery connected in series with a 2 ohm and a 4 ohm resistor. And usually we're asked to determine the current which is going to flow in that circuit. Well, to do that we must find out the total resistance of the circuit. So we know the equation for a series resistors. We have the total resistance in series is just simply equal to R1 plus R2. So in this case we have 2 ohms and we have a 4 ohm resistor. And that's going to give us a total resistance of 6 ohms. Our next part of the question then is to find the current in the circuit. We'll use Ohm's law and we rearrange to find the current I is equal to the voltage of the battery divided by the total resistance of the circuit. We know the voltage of the battery is 12 volts. We know the total resistance of the circuit is 6 ohms. So therefore we can say that the current flowing in the circuit is 2 amps. So we can say around this series circuit is a current of 2 amps. So that's how we work out the first basic questions in circuit theory. Obviously the next one is to find the potential difference across each resistor. Now it's always a good habit to go to the resistors in question and underneath them make up a little chart of all the sort of variables that you'll be dealing with. In this case for any resistors V, I and R. So the resistance of this circuit is 2 ohms. We know the current passing through it is going to be 2 amps. So therefore the voltage across it, or the potential difference across it, is going to be 4 volts. Now we don't need to do the second calculation because we know that if there's 4 volts dropped across the 2 ohm resistor, then to add up to the supply voltage of 12 volts, there must be 8 volts dropped across the 4 ohm resistor. But we can still use a theory to show that. V, I and R, get into good practice of putting V, I and R below the resistors in question. And we know that the current I is going to be 2 amps because it's a series circuit. And the resistance is going to be 4 ohms. So therefore the potential difference is V equals IR is 2 times 4 is going to give you 8 volts. So there you go, we have 8 volts of potential difference across the 4 ohm resistor and 4 volts across the 2 ohm resistor. Another question which might creep in is this one here. It says find or determine the power dissipated in the 4 ohm resistor. Well, the power equations are as follows. We know the power equations are power equals VI, which also equals I squared R, which also equals V squared divided by the resistance. So really we can choose any one of those there. So if we put our next variable down here, we could put down power. We can work out really any of these equations here. And we'll stick to the simple one, P equals VI. So the power dissipated or lost in this 2 ohm resistor is V times I is going to be 8, and units for power is the watt. In this resistor here we have the same idea, power equals VI, or we could use I squared R, or we could use V squared over R, whichever is suitable, whichever we have the enough data for. So let's try I squared R, because we have got I after all, and we have got the resistance. So I squared R is going to give you 2 2s of 4, and 4 is 16. So we're going to have a total power dissipated in that circuit. That means energy lost over a given time is 16 watts. And that adds up when you look at it, because the 4 ohm resistor has got a bigger resistance. So it's going to have to soak up a lot more, double the power, or double the energy than the 2 ohm resistor. So we can use any of those equations here, but keep your work in order so that under the resistor you can see all the data building up. Now what other question could they ask you in circuit theory? Well, they could ask you this one here. Find the amount of electric charge that flows into the 2 ohm resistor in a time of 2 minutes. Now that equation is from the data book. We know that the current I is also equal to Q divided by T. So if we're rearranging, we get Q is equal to IT. So we look at the particular resistor in question. In this case it's the 2 ohm resistor, and we know the current going through that is going to be 2 amps. So therefore Q is going to equal to 2 amps times the time it's been flowing for 2 minutes, but you must change it into seconds. So it's going to be a case of 2 times 60 to give you seconds, and we work that out. We get 2 times 2 is 4, 4 times 60 is 240, and units for the charge is capital C, coulombs. So that's just a little example of the type of questions you could be asked circuit theory wise. You could be asked any of these questions, and it's always good to be organised and keep all the data under resistors in question.